Hey guys, happy Sunday. Hope you guys had a good weekend. So this session, you guys have completed chapter 8, but I wanted like I promised you guys, I was going to cover two things, and we'll have them in two different sessions. One of the things is where we're going to cover VTP, VLAN trunking protocol. It's mentioned in the chapter. I want you guys to know about it, but it will not be in your CCNA. Okay, Cisco has stated that that is no longer a objective on the CCNA 200-301. Okay. Um, Also, we would be looking more in depth in the next session on DTP, dynamic trunking protocol. Okay. I want you guys to understand how VTP works because there are architectures out there that still use it. And they're using maybe VTP version 2, right? Version 1 and version 2 instead of version 3. And maybe we may have a cybersecurity risk out there, and maybe you just can't change that. I mean, they just left it in place. It'll be up to you, being that network, that hybrid network guy, maybe that has two-dimensional, three-dimensional skills within another sector that's in charge of managing it. So let's go over it. So what is VTP, right? Well, VLAN trunking protocol, right? What it does, it was basically our first look at automating, right? Automating a time-consuming task, right? So if we have architecture, right, and we have switches that we have to build, by default, right, we would need to configure, right, VLANs on one switch to be able to talk to another switch with the same VLANs and that host, right? So that they can communicate with hosts that live on the same broadcast domain, right? I'm just talking between two switches. What happens if we go ahead and we add 50 switches to our architecture, right? We would need to add those same VLANs all to those 50 switches. That's pretty time consuming, right? So what Cisco did is they created a technology called VLAN trunking protocol, right? Which will let us create VLANs on one switch, and it'll propagate, or AKA the proper term is synchronize, to all other switches. Okay, so there's a couple of different modes that help this work. Help a VTP architecture work. We have VTP server mode, we have VTP client mode, and we have VTP transparent mode. Okay, we'll go over those in a little bit. All right. One concept that I want you guys to understand about VTP, and it's very important, very and also very dangerous as well, is VTP configuration revision number. That's very important, and we'll go over why in a little bit. Also, of course, you know, there will be VTP advertisements on links. So we'll take a packet capture and we'll see how that looks. But in simple, let's go ahead and let's create architecture to where we have a VTP server configured on every switch. Okay, so let's pull up switch 1. Now, let me explain what a VTP server can do, right? Basically, switches that are set to VTP server mode. They can create, modify, and delete VLANs. They can synchronize with themselves, and of course, they can forward VTP advertisements. Okay, so let's do that, right? First things first, let's check what mode, right, that these switches are running in. Okay, move this over here. There we go. Oops, didn't mean to do that. There we go. Let's get into this one. Let's reset that. There we go. Let's get into that. There we go. All right, so let's do show VTP status. Okay, couple of things here. right? Okay. All right. So when we run the show VTP status, we're going to see the VTP versions that are capable of running on the switch, right? That second row is going to show us the VTP version that's currently running. Of course, right now it's running version 1. One key thing, right? What actually enables VTP to work within architecture is your VTP domain name. All switches need to have the same VTP domain name for your synchronization of VLANs to work. Okay. All right. Um, VTP pruning mode, of course, VLANs can be pruned, right? If this is enabled, VTP traps generations. Of course, we can enable traps to propagate whenever a change happens within the VTP architecture. Okay, and of course, we have the device ID, which of course is the system MAC address. Okay, so if you're tracking who the VTP server is within your architecture that may have VTP clients, you can track it by looking at, of course, the VTP server configuration, right? Of course, we can also see, right, when the configuration was last modified, right? And we'll have IP address associated if configured, right? If we have an IP address configured or what have you. And of course, we'll see our own IP address here, right? The switch, of course, is telling us through this verification command that we don't have any layer 3 instance configured on this switch, right? So it's going to be 0.0.0.0. Okay. All right. Let's move on to the second section of this verification command, right? So it tells us what operating mode is this switch running in, right? In regards to VTP. Well, it's running in server mode. Okay. All right. This is the maximum amount of VLANs that's supported locally. All right. Number of VLANs existed. Again, by default, we got 5, right? Configuration revision number. I told you guys about that, right? An MD5 digest, of course, MD5 secure. But of course, this is more on the lines of that encryption side. Okay. So how can we go ahead and get this to work, right? The main thing to get this to work is configuring a domain name, right? But of course, let's see this in just a normal state. We have all the switches configured. Let's confirm they're all running VTP. Okay. All right. So they're all running VTP. Configuration revision number is 0. All right. All right. So what happens, right? Since they're all running VTP, it should work, right? Let's configure a VLAN. Okay. So let's do VLAN 10. Give it a name. Okay. Let's do 20. All right. Let's configure VLAN here. Let's do 3. All right. So if we go ahead and verify, let's see, nothing changed. All right. A configuration revision number, which I expected to go up, didn't go up. All right. And let's see if we have the different VLANs, since they're all a server. Let's see if the VLANs propagated to other switches. It did not. All right. One of the key things of getting VTP to work is we need to configure a domain name, right? That is how they sync up, right? And that's how they make this configuration work. So let's go ahead and do that. All right. So let's hop out of here and Let's play that out. Okay. In our environment right now, we got 3 VLANs. We got VLAN 10, VLAN 20, and VLAN 30 on different switches. Okay. Let's change that. Okay. And let's name it. There we go. VTP mode. Server. Even though it's already set to server mode, I just like to verify. Okay, let's do the same thing here. All right, VTP mode server, and let's set the domain name. Okay, do this. Okay, we'll talk about that syslog message that popped up in a second. Okay, okay, VTP IRO. Okay, all right. So we get a pop-up message just telling us that the domain name change for VTP. This is very important for the control plane to go ahead and show us this change, because again, it can affect the architecture, it can affect traffic flow, and it can again modify broadcast domains on our switches. Okay, so let's take a look at this. Show VTP status. Okay, all right. So what do we see now? We see the configuration revision number changed to 1. Okay. Okay. Configuration revision number changed to 1. Okay. So let's check our VLANs, right? Since that configuration revision number change, right? So, okay. So we got Donkey Kong. Okay. So we got all of these here. Okay. So let's go ahead and do this. Just make this change right here. Okay. So now that we have this configured, go ahead and configure our trunks. Okay. All right. So now switch 1, right? Okay. Oh, that's right. Old code. Okay. Switch port. Oops. Calculation. Q. And again, guys, reminder, on the newer 9K switches, you don't have to put .1Q. That's already assumed by default. Okay. Save that. Okay, let's do that. Let's do that as well. Forgot that one port. /1. There we go. There we go. /1. And I'm sure you guys saw that change. Switchport.1Q, switchport encapsulation .1Q, switchport mode trunk. Go. Switchport. Okay. Let's clear all this out. All right, do some verification. Status. Okay. MD5 digest check some mismatch. Okay, we'll do that. We'll check that in a second. All right, let's do this. Show VTP status. Oh, there we go. All right. As long as we have a mismatch, we can not worry about that. Okay. Okay. All right. So you guys typically would go ahead and see this sometimes when, of course, we pre-configure some stuff a little bit early. All right. We can go ahead and make sure that we have the proper configuration, and we make sure we have all the VLANs the same. So let me go ahead. I'm gonna go ahead and double back and change the VLANs that we do have configured. Brief. I'm gonna delete Zelda. No VLAN 10. There we go. 20. Okay. No. Whoops. No. All right. There we go. All right. So guys, remember, if you ever want to fix your, or you see an MD5 digest mismatch, it's typically because you have configuration revision numbers that were changed, and of course the MD5 digest is always changed whenever you make a configuration revision, right? We added our VTP switches, which are all servers, to the domain, right? We did it out of the order of operations. And we had different VLANs. That's why you went ahead and saw the different digests, and of course we got that error, right? And so of course, if we go ahead, we do this to show VTP status. we're going to see the error for MD5 digest is gone, right? So let's go ahead and now let's configure those VLANs back, right? Now, our architecture is all of them are running in server mode. Okay, so let's go ahead and configure different VLANs on there and let's see what happens. So let's do the VLAN 10 name. I'll call this Zelda. Okay, and let's do 20 name. Okay, and let's do 30 name. Let's do Donkey Kong, just like before. All right. So since they're all VTP servers, what can I expect to see? Okay. So we have number of VLANs are 5. Okay. And we have the VTP domain name to be Hyrule. Okay. Configuration revision number, right? It is set to 2. Let's go ahead and, oopsies. Let's go ahead and check everything else as well. Okay. All right. Okay. Excellent. All right. So we see number of VLANs are 5, right? The VLANs haven't propagated yet. That could probably be a software thing. But let's go ahead and let's scroll it back and let's go ahead and configure the different modes on switch 2 and switch 3 to act as clients, right? So you can see actually how VTP modes in a server client mode. So let's switch this to client. Let's exit here. It's all about context. VTP mode client. Excellent. Let's do that. VTP mode client. Okay. All right. Okay. Now, show the status. Excellent. Okay. Show VTP status. Okay, excellent. Okay. Now we got it set as a client. And let's verify our configuration. And I do see the number of VLANs went up. So like stated, since we're emulating switches, it probably takes a while. So we probably got those VLANs that we created on the other switch. Okay, configuration revision number. We see it changed to 4. Whenever you change the mode as well, right, within your VTP architecture, that's going to cause a configuration revision number. Okay, so you guys need to remember that as well. Any change to your architecture will go ahead and trigger a configuration revision number update. Okay, so let's go ahead and check what our VLAN look like. Okay, so we have 1, 2, 3, 4, 5, 6 VLANs, right? Let's go ahead and it looks the same. Let's make sure it looks the same everywhere. Okay. Okay. So Zelda propagated, all right? And maybe it's taking some time here. There we go. Okay. All right. And let's, probably we're having some software issues. Let's delete VLAN 20. 20. Okay. All right. So it's not allowing us to do that. So we're going to have to move forward. Okay. So let's do VLAN 20. Name, what do we call this? Link. Okay. All right. So our test is going to be switch 3. Let's take a look. So VTP status. All right. That configuration revision number should change. So VTP status. All right. It looks like it's not propagating to the other switch as well. Probably got a layer 1 issue here that we can check. Yeah, let's check that. Show running config 0, 1, 0, 1, 0, 0. We don't. Probably something else going on. All right, no worries. So let's do show VLAN brief, right? Which is our main client. Okay, we got VLAN 10 and VLAN 20 here. We got Zelda and Link. Let's check our VLANs here. So VLAN brief. All right, we still got Link. And let's check our connection there. Show run interface gig 070. Okay. All right, so that looks good. And let's kill this connection. There we go. That's what I figured. Okay. Yeah. Software sometimes, man. I'll tell you. All right. Go. Yeah, it's gonna do that. Okay. Let's do that. Let's do that. There we go. We got that. So now let's take a look. Again, sometimes software messes up whenever you try to emulate it. So of course that's why you always hear get actual hardware switches. Okay. All right. So let's take a look and see if it's working as expected now. Okay. There we go. So status. There we go. All right. All right. So it went up to 7 VLANs. So I think we just had a layer 1 issue via the emulation. Okay. Show VTP status. Okay. All right. Excellent. So let's check our VLANs. Brief. Excellent. So brief. Excellent. Of course, what I expect, if I do a show VLAN brief, all that's popping up, right? So this is the first glimpse of automation that we saw way back in the day, right? What happens, right, if we go ahead and we take a look at what a VTP client can do? Well, there's a limited amount of what VTP clients can do, right? Can VTP clients create, modify, and delete VLANs? Let's take a look. Let's see if we can. The VTP VLAN configurations are not allowed when device is in client mode. Okay, so you cannot. I want you guys to remember this, of course, just for your career. Again, it's not on the exam. You cannot configure VLANs whenever a switch is in VTP client mode. Okay. Does it synchronize with itself? Yes, it does. Does it forward advertisement? Absolutely. Okay. Okay. Well, there's another mode that we have here, right? That we can go ahead and implement if we wanted to right? If we wanted to not have the switch be a part of the VTP architecture, but we wanted it to be able to forward VTP traffic to other switches, that mode is called transparent mode, right? VTP trans mode, those switches can, of course, create, modify, and delete VLANs locally, right? It does not synchronize with itself, right? But it does forward, right, those VTP advertisements. Okay, so let's go ahead and change the switch to, right, transparent mode. Okay, right? Let's take a look at our VLANs, right? Now that we made that change. So those VLANs don't go away, right? We have what we have configured in our VLAN.dat file, right? VLAN.dat is on every switch, right? That's your VLAN database that holds all your VLANs that's configured, right? Let me go ahead and now create some VLANs, right? And we'll leave that VLAN 40, 50, right? VLAN 60. Okay, we have that, right? Let's kill the connection. And I believe that change, we made that change on switch 2. So let's kill the connection between switch 3 and switch 1. Okay, right? So we killed that connection. What happens if we're creating VLANs here, right? We say VLAN 100. Name management, right? We only have a connection between switch 2 and switch 1, right? For switch 3, right? If it's how I described, right? Switch 2 operating in VTP transparent mode should forward that advertisement, right? Let's take a look. Okay, configuration number 5. So, okay, configuration revision number 6, right? Let's see if we got an update here. Okay, configuration revision number, right? It's updated. Let's see our VLANs. Okay, what do we see here, right? Even though, right? Even though switch 2 is no longer participating in VTP activities in regards to modifying, creating and deleting VLANs, right? And it's no longer synchronizing with itself. It's still forwarding those advertisements, right? If we go ahead and do a show VLAN brief, right? We don't have the management VLAN that we created on switch 1. Okay. So again, VTP server, it can create and modify and delete VLANs, right? The VTP server can synchronize with itself, and VTP server can forward advertisements, right? A VTP client cannot create, modify, or delete VLANs. It can synchronize with itself, and it also can forward advertisements. A switch that is in VTP transparent mode within a VTP architecture, it can create, modify, and delete VLANs locally, okay? It does not synchronize with itself, which is needed for the VTP configuration, right? VTP architecture, right? That's running in server and client mode. But it does forward advertisements. Okay, right? So what are the dangers here, right? What are the dangers? We talked about all the good things within a working state, right? We did, right? So what happens, right? Let's go ahead, right? And let's say we go ahead, right? And we do this, right? And we say, go to show VTP status. Okay, right? All right, we said it's a higher rule, right? We got a higher revision number, right? Show brief. Show VTP. Okay, right? Show VTP status. Okay. All right. Revision number is 10, right? Let's add a few more things, right? Let's add this. Okay. Let's say we were playing with the switch in our lab, right? We were testing out VTP before we decided to implement it. And we said, you know what? All right, this is a good switch. Let's go ahead and add it to our architecture, right? Well, the engineer forgot to go ahead and make some changes, right? So we went ahead and we did this, right? And let me show you what the engineer did. Can I do this? Oh, there we go. All right, let's give it a second to boot up. All right. Okay. Yeah. All right. Excellent. So let's finish. Okay. It's going through post, telling us what is running, what's good to go. All right, let's give it a second to go through this. Okay. Once it gets through all these interfaces and syslogs, all right, should have gave it some more CPU. Okay. All right, all right, all right. Thanks for checking all my interfaces. Mhm. There we go. Okay. All right. So since we now have our test switch that I was playing around with, right? And my boss, Antoine and Kivia said, all right, thanks for that proof of concept of VTP. Let's implement in our architecture, right? Right. And I worked with Gary. Gary already implemented an architecture, right? Because it's been a couple of months ever since the PLC, but we needed another switch to go ahead and supplement a new department, right? For the space that we're acquiring, right? So let's do this. Let's see what happens, right? When we do this, right? Okay, okay, okay. 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 So, status. Okay. Let's see. Okay. Let me make sure we have a higher revision number. Okay. So VTP status. Status. There we go. Okay. Let's do VTP domain. Okay, excellent. So we got that. Let's configure our interfaces for trucks. Interface bit 0. Encapsulation. Switch port. Okay, so we have that done. Give it a name, host name, test, switch. All right, so let's go ahead and add some layer one configs. Okay, there we go. Got a link. Let's add a link here. Go. Okay, let's see if we have a change. Let's clear this out. Okay, all right, so no change just yet. I expect an MD5 digest error, right? Let's go ahead and check the other switches. Okay, and it may take a while, guys. Okay, so VTP status. Okay, status. Whoops. Yeah. Okay. All right, and let's test that. Status. There we go. Let's see if it's propagated yet. It may take a while. So VTP status. There we go. Okay. First, we got to change this back to client. There we go. Status. Look. Okay. And let's reinitiate that. Okay. Mode. All right. Okay. Take a look at that. So status. Okay. And let's check this. Status. Okay. So we have a higher revision number. Was it 13? Our current revision number is 13. Okay. Remember, right? Antoine and Marquivia told us we need to add another switch because we got a new department in our building. Okay. Um, but again, this is the same switch that we were giving our proof of concept of VTP with to Antoine and Marquivia, right? So we saw the number of VLANs that existed increased. Let's do a show VLAN brief. So now, what do we see? We see all the VLANs that were created before that was actually working in our production environment. They have all been erased. They've been erased. Now we have an outage. Yes, we have an outage. All VLANs have been deleted due to VTP. Okay. You have to be very careful with VTP, right? Um, a lot of instances, a lot of horror stories that you'll find out from engineers of the past will say VTP is very dangerous. Um, it's not a technology that they like to use. Um, True automation now, of course, you manage all your switches using a scripting language, a programming language, and you'll go ahead and pass that configuration down, and it'll propagate all the VLAN configuration down to your switches. I just wanted you guys to know about this from a layer 2 technology perspective. Know how this works, know the positives, right? Know the dangers. Okay. All right, guys. I'll go ahead and end this one, and you guys have a great day.
Thanks,
Thanks, Dave.
David. Bye,
All right, guys.
guys.
Bye.
Thanks.